Now, going over our double replacement reactions practice problems. Okay, so aluminum is Al with a +3 charge. Iodide is I with a -1 charge. We crisscross. Mercury is Hg with a +2 charge in this case. Chloride is Cl with a -1 charge. Crisscross, and we get that. Now, in double replacement reactions, we're going to take these two ions and put them together. Al has a +3 charge. Cl has a -1 charge. So we crisscross that way. And we're going to put the inner two ions together. So Hg has a +2 charge in this case. I has a -1 charge. So we crisscross like that. Now we're going to balance. 2 Cl's, 3 on this side, so the least common multiple is going to be 6. So we're going to put 3 Hg's here, and we're going to put 2 here. So we got to fix this. So 3 Hg's, 6 I's, 6 I's, 2 Al's, 2 Al's. Okay, so it should be balanced. Now our last step is to do our solubility rules. So all compounds containing I are soluble except for silver, mercury, lead. So we write AQ past it. Okay, all compounds containing Cl are soluble except for silver, mercury, lead. Okay, so this is going to be a solid. All compounds containing chloride are soluble except for silver, mercury, lead. Going to be soluble. All compounds containing I are soluble except for silver, mercury, lead. Okay, so that's what our reaction looks like. Silver nitrate. Silver is Ag with a +1 charge. Nitrate is NO3 with a -1 charge. Potassium is K with a +1 charge. Phosphate is PO4 with a -3 charge. We crisscross, and it looks like that. Now we're going to take the outer two ions and put them together, and the inner two ions and put them together. Okay, so we get Ag with a +1 charge, phosphate, -3 charge. We crisscross. Plus K and NO3, we put those together. K has a +1 charge, NO3 has a -1 charge. Okay, there's no need to crisscross this because they're equal and opposite charges. Now we got to balance. So we have 1 phosphate, 3 Ks. I need to put 3 Ks on that side, 3 NO3s, 3 NO3s, 3 Ags, 3 Ags. It's balanced. Now let's go through and do our solubility rules. All compounds containing NO3 are soluble. So we write AQ. All compounds containing PO4 are insoluble except for NH4 and group 1 metals. So group 1, potassium's in group 1, so this is soluble. All compounds containing PO4 are insoluble except for NH4 and group 1. Silver is not in group 1, so it's a precipitate. All compounds containing NO3 are soluble, so you write AQ past it. Next example problem. Symbol for copper is Cu. It has a +2 charge. Symbol for bromide is Br with a -1 charge. We crisscross. Looks like that. Aluminum, Al with a +3 charge. Chloride is Cl with a -1 charge. We crisscross. It looks like that. Now, we're going to take our outer two ions and put them together, and our inner two ions and put them together. So, copper has a +2 charge. Chlorine has a -1 charge. Looks like that. Aluminum has a +3 charge. Bromine has a -1 charge. So we crisscross, and it looks like that. Now, when we go to do our let's go and balance it. So we got 3 Cl's, 3 Cl's, 1 Al, 1 Al, 2 Brs, 3 Brs. Okay, so we have to get the least common multiple between 2 and 3 is 6. So this is going to change this up. Okay. Hold up just a sec. That's not going to work. I mess up. Okay, let's start over balancing again. Oh, this is why. This is supposed to be a 2. Sorry. So the least common multiple between 2 and 3 is 6. So we put a 3. 2 times 3 is 6. We'll put a 3 in front. 3, 6, and it bounces that way. Sorry about that. Okay, so when we go to do our solubility rules, all compounds containing bromine are soluble except for silver, mercury, lead. So we write AQ behind it. All compounds containing Cl are soluble except for silver, mercury, lead. Right, AQ behind it. All compounds containing chlorine are soluble except for silver, mercury, lead. All compounds containing bromine are soluble except for silver, mercury, lead. So technically there is no reaction on this question because everything comes out to be soluble. Okay, occasionally that happens. So, next question, calcium acetate. Calcium is Ca with a +2 charge. Acetate C2H3O2 with a -1 charge. We crisscross, it looks like that. Sodium is Na with a +1 charge. Carbonate is CO3 with a -2 charge. We crisscross, and it looks like that. Now, we're going to take our outer 2 ions and put them together, and our inner 2 ions and put them together. So we get CaCO3 with a +2 charge, -2 charge, plus NaC2H3O2. Sodium has a +1 charge, acetate has a -1 charge. Now we're going to balance. So I'm going to start balancing here. So 2 acetates on this side, need 2 on this side, 2 NAs, 1 CO3, 1 CO3, 1 Ca, 1 Ca. It's balanced. Now we're going to go through and do our solubility rules. All compounds containing acetate are soluble except for, there are no exceptions, so we're at AQ. All compounds containing CO3 are insoluble except for NH4 in group 1. Sodium falls into group 1, so it is soluble. All compounds containing CO3 are insoluble except for NH4 in group 1. Calcium's not in group 1, it's in group 2, so it produces a precipitate. All compounds containing acetate are soluble, so write AQ. Okay, last 2. Ammonium is NH4 with a +1 charge. Chloride is Cl with a -1 charge. No need to crisscross because they're equal and opposites. Mercury is Hg with a +2 charge. Acetate is C2H3O2 with the -1 charge. We crisscross, and we have to use parentheses because we're crisscrossing to a polyatomic ion. Okay, we're going to take the outer 2 ions and put them together. This has a +1 charge, this has a -1 charge, so there's no need to crisscross. And we're going to take the inner 2 ions and put them together. Hg has a +2 charge, Cl has a -1 charge, so we crisscross like that. Okay, going through, let's balance this thing. 2 acetates on this side, I need to put 2 acetates on this side, 2 NH4s, 2 NH4s, 2 Cls, 2 Cls, 1 Hg, 1 Hg. It's balanced. Okay, now we're going to go through and do our solubility rules. All compounds containing chlorine are soluble except for silver, mercury, lead. So this is soluble. All compounds containing acetate are soluble. All compounds that contain acetate are soluble. All compounds that contain chlorine are soluble except for silver, mercury, lead. This falls into the exceptions, so we write S, and we're done. Last example. Calcium is Ca with a +2 charge. Bromine, -1 charge. We crisscross like that. Potassium is K with a +1 charge. Hydroxide is OH with a -1 charge. No need to crisscross because they're equal and opposites. I'm going to take the outer 2 ions and put them together. Like that. Calcium has a +2 charge. Hydroxide has a -1 charge. Okay, and then we're going to take the inner 2 ions and put them together, K and Br. Like that. Okay, so Let's balance this thing. So we have 2 hydroxides on this side. Let's put 2 right there. That changes your Ks. 2 Ks, 2 Ks, 2 Brs, 2 Brs, 1 Ca, 1 Ca. It's balanced. Now let's go through and do our solubility rules. All compounds containing bromine are soluble except for silver, mercury, lead. This does not fall into an exception, so we write AQ. All compounds containing OH are insoluble except for group 1, calcium, strontium, barium. Potassium's in group 1, so it falls into an exception, so we write AQ. Hydroxides. All compounds containing hydroxide are insoluble except for group 1, calcium, strontium, barium. It falls into an exception, so we write AQ. And all compounds containing bromine are soluble except for silver, mercury, lead. So this doesn't fall into an exception, so it's AQ. Since everything is AQ, there's no reaction that actually happens, okay? So on your test, I'm gonna give you something that actually reacts. So don't worry about that one. And you will have to use your solubility rules. If you have any questions, feel free to reach out, and hopefully you have a good night. Thanks.